So,
What's that? What did you get? Like
writing, okay, so I got questions.
Yeah, you make it sound like she's an ag. Wait a minute.
I got 2 questions from the unit test at this point. If you did not email me a question from the unit test, you need to come during advisory, that pseudo-advisory time to ask me questions about the unit test. You have to do, actually, I will give you until next Tuesday to do your retest because I did not even have the test ready for today. You have to do your retest by next Tuesday. That is it. We're testing on Unit 7 Thursday, so yeah. Tonight, what's up?
Did you see the email about the reschedule for the month?
That is only for seniors.
Oh, okay. Okay.
All right.
Do you know what time we have to be there though for like to get ready for graduation?
You have to be there like around an hour.
Yeah, so like 12 something. Yeah, we wouldn't make it.
Okay. So the only 2 questions I had for the test so far are this number 3 that I gave back, and number 5. And so we're going to go over those. Again, if you want to,
Are we gonna go over progress check questions?
we're going to go over 4 progress check questions. So not the ones I already answered you about, but others. Actually, it might be one of
Is
those.
there a particular color of marker that you like?
Yeah, the same ones that Mr. Kinney buys specifically for himself. Suppose a hypothesis test will be used to investigate whether the proportion of U.S. adults who have been a victim of a cybercrime, such as identity theft, is greater than 0.25. Suppose that the hypothesis test is conducted using a significance level of 0.05 and the power of the test is determined. Hey, give me one of those, honey. Like, where are all my purples?
No!
Can you see? Like, okay. I was wondering.
And the power of the test is determined for a specific alternative value using the significance level of 0.05. So, as a reminder, what is the power of a test?
The opposite of like the other thing.
The probability
Yeah.
of
Getting it right.
Correctly reject the
Specifically, correctly rejecting the null hypothesis, right? So, it is the complement of the beta, the power of a type,
Yeah.
probability of a type 2 error.
Can you say alarm so I can see that?
No.
Oh, okay.
So it is the complement of that, but there's a couple of things to remember, and it's not inside this question, so I'm going to go ahead and address this. Remember, let's say that this is the distribution for my null hypothesis. Which of these would I be more likely to correctly reject my null? Here, so this is my p hat, or it could be x bar, whatever, or this one.
Second one.
Yeah.
The second statistic, right? The further our statistic is from the null hypothesis, the easier it is to correctly reject the null. Now, that means really we test the power at different values because we don't, and run simulations because we don't really know what the null or what the true proportion is. We just have statistics. However, what we do need to remember is this. If alpha goes up, and I will say this, I don't ever go directly from alpha to power because that's a confusing trip for me. What I go to is beta. If alpha goes up, what happens to beta?
Beta goes down.
Beta goes down, right?
Oh, and then power
And then
goes
the
up.
beta goes down,
Okay.
power goes up. Okay.
So power increases. And so that is what we need to remember is that relationship between alpha and beta, the probability of a type 1 error and a type 2 error. So if I'm more likely to make a type 1 error, I'm less likely to make a type 2 error, so my power is going up. And the inverse of that, right? So if alpha goes down, so I'm less likely to make type 1 error, my beta goes up, and my power goes down. And how does my sample size affect alpha and power?
What's the sample size increase?
Power goes up. What?
What?
You know that there's other people who do start talking before you sometimes, Jaden, right? I
Sample.
love you, but like,
I couldn't hear.
respect for other people.
That's the
I
first
couldn't
time
hear.
I've heard say
What were you about to say something? What were you about to say, Trina?
Sample size increase, the probability of beta decreases.
So as our sample size increases, beta, the probability of a type 2 error goes down, which agrees with what you were saying, Jaden, that the power goes up, okay? How does it affect alpha?
It stays the same. Yes, it stays the same.
It stays the same. Remember, The probability of a type 1 error, she has to go to a doctor appointment. The probability of a type 1 error is only determined by alpha, and we set what alpha is, okay? So sample size does not affect that. That is why, and actually I already circled the answer. What was the answer for number 3?
B.
B, okay.
Wait, so if alpha goes up, then sorry, I'm trying to think of what was I gonna.
So remember, alpha and beta are
Yes.
inversely related. So
No,
if alpha goes
yeah.
up,
No, it's not
Okay.
like, I'm not asking about like the relationship between alpha and beta. It was like, alpha is like, and the significance level, right? So if the significance level goes up, then is it more likely to have a type 1 error or less
Yes.
likely?
because the whole idea is
Uh-huh.
if alpha is 0.05,
Yes.
there's a 5, so like in this region, so here is my null hypothesis,
Mhm.
right? So this area is 0.05. So is it possible that I get in this region and the null is true?
No, wait, I don't know. I don't know
I
what
mean,
you're trying to
like-
say.
It's a part of, it's possible to get in this region, get a statistic way over here,
Yes.
and this was actually true.
Yes.
It's not likely.
Mhm.
So like it could be like the probability that p hat is greater than, I'm making something up, 0.8, okay, is equal to 0.03. So it's not likely that I get that statistic or more extreme, but it is possible to get this value when the null is true, okay? So what was the chance that we made an error? A 5% chance that I get inside this region, reject my null, but the null was actually true. So that's where like, if we think a type 1 error is really, really, really bad, then I'm gonna change this alpha to a 0.01, so there's only a 1% chance of making that error. Which would cause my beta to go up. If I think my type 2 error is worse, I'm actually gonna change alpha to a 0.10, so it is easier to reject my null, making it harder to make a type 2 error.
That's the one.
That's the idea there.
Okay, thank
Okay.
you.
What do you mean?
Thank you.
Good. Alright,
Didn't make that noise.
this number 5 was one in a couple different ways that a lot of us got distracted on.
I don't
D and C were the two most common. Now, first things first, you got to be careful. This came up on the progress check and I need to see it here. Some people were thinking that this should be a 2-sample test. Especially on the progress check, I saw that. But right here, this is the what? Population. That's not a sample, that's a population, right? That's my null hypothesis that P is equal to 0.3. Alright, there's my null. Well, I should say P sub 0. Null hypothesis. That's what I'm testing against. Now, the 20 had a wingspan greater than 10 inches, but what's P hat in this case?
I don't know.
Well, how do we calculate a sample proportion? It'd be 20 divided by,
The standard error.
no, P hat, just the sample proportion, ladies and gents.
Oh my god, that's why I was confused.
It's out of how many?
No, I just wasn't doing proportions.
Oh, what'd you do?
I think I was doing mean stuff.
Okay.
because We had just.
We need to recognize, yeah, we just started, but remember, this is why we gotta keep in mind, like, when I see the word percent, that's an instant proportion idea.
Yeah.
Yep, so it should have been 20 out of 80. So C is out, because that's 25%. And then when we look over here, we gotta remember, there's two different formulas. There's this one. And then there's this one. Which one am I supposed to use in this case?
You said population?
So,
What-
the S or the sigma?
Sigma.
Why sigma?
Because you have the population.
If
stuff.
you have a P, a hypothesized population proportion, use your P. Okay? If you don't have a hypothesized value, use P hat. So notice that language. When are you going to use P? When you have what type of inference procedure?
Population proportion?
Yes, but when are you going to have a population proportion? In what? What type of tests are they called? They're called significance tests, but you've also heard me call them what a lot? hypothesis test, right? When you hypothesize a p-value, you use this for the significance or hypothesis test. So when are we going to use this one?
When you don't have a population proportion.
When is
For
that going to be?
confidence interval.
So a confidence interval. Remember, a confidence interval, and so be careful, we don't ever actually have the population proportion. If we did, there's no need for an inferential procedure. But if I have a hypothesized population proportion, a hypothesized p, I use this. If I don't have a hypothesized p, like with confidence intervals, that I'm using to estimate p, I use this. Okay? Small detail, but wicked important. That's the tricky part. Like the standard error formula is the tricky part about proportions. The matched pairs design and t-distribution is the tricky part about means. But be careful and attend to those details. Alright, those are the only two. We had questions there, progress check, couple of questions, and then we're rocking and rolling on the DYU.
Alright, it was a different
Alright, so right here, this was the example I was talking about earlier. A marketing, so 4 out of the 5 people who completed this progress check, which gives me, I don't know, 4 people who did not even attempt it. We gotta fix that, guys. Hard to study if we're not doing progress checks and doing these things. A marketing executive is investigating whether this year's advertising campaign has resulted in greater mean sales compared with last year's mean sales. This is where a lot of us picked that we thought it was a 2 sample. But I need you to look, like, how many actual samples are referenced in this problem?
one.
Only 1 sample, right? We are comparing against last year, where we have a hypothesized value, right? So first off, when we use a test for means, do we use z-test or t-test?
T-test.
Why do we use t-test again?
Because
Because it's not a
the degrees of freedom makes it,
It covers more area.
has that more area in the tails.
But why do we need more areas in the tails?
Because we're
Because there's-
measuring the stuff in the tails extending.
It's quantitative, not categorical.
Okay,
it's
so
more-
we're forgetting something from like the very first lesson or so. I need y'all to hear me on this. Listen, we don't have sigma. Remember, the true standard deviation of the sample means is the population
true
standard
sigma.
deviation divided by the square root of n. But we don't actually ever have this. If we had this, we probably had mu. We don't need inferential procedures. So remember how we looked at the that applet, and when we checked the capture rate, the confidence level was way off? We got to remember that, or the confidence interval capture rate was way off. And so we had to use something different. We had to use t, which had more area in the tails, so that we could get the right capture rate. And so it's not 2 sample, and it's not a matched pair, so it's not 2 sample. So what's the only answer left?
1 sample t-test for a population.
Population mean. Make sure you're paying attention to means versus proportions every time we're gesturing.
I think I was just confused because they were doing the comparing stuff and I'm like, maybe they just forgot to say that he has to have.
Yeah. So remember, like, we have to have a p-value for our hypothesize, and so we're comparing against last year's sales, whatever it is. Or, no, we're talking
Oh, okay, I get it. Last year is the null.
about means. Yes.
Okay.
Last year is what we're comparing against to see, did we increase? Alright, numbers 1 and 8. But yeah, if they only collect 1 sample, it can only be 1 sample. Sociologists studying the difference in ages between husbands and wives contained a random sample of 55 married couples. The mean of the husbands' ages was 38.5 with a standard deviation of 12.6. The mean of the wives' ages was 36.9 with a standard deviation of 12.4. The sociologists calculated the difference between the ages for each couple, and so we had a mean difference. And then it talks about a matched pairs hypothesis test. Now I need y'all to hear me on this, because we're going to do more work with this. However, before they even told us matched pairs, then we should have known it was a matched pairs.
Because it's husbands and wives.
Husbands and wives.
55 married couples.
55 married couples. Does some of the variability within the husband's age relate to the wife's age?
Yes.
It could.
It is much more likely that someone, a male age 37, is married to a female age 35 than say a female 35 married to a male aged 80, right? Like that's much more likely 37 to 35. Some people want to try to be gold diggers, but the normality is not there, right?
Who says it's gold digging?
That's true. Love is love.
Yeah.
We're in love.
Yeah, okay.
Who says it's gold digging, huh?
Okay,
But my whole point is, once again, they're matched up, right? If they're matched up in respect to the variable of interest, then we should find the difference first and then find the mean difference. And so, yes, they're matched up together like that. Matched pairs design is important. If there is a significant variable that connects the two, then that's important. The other thing to remember is, with a two-sample test, two-sample interval, the samples need to be random and what?
Independent.
Independent, right? Are those independent in random samples?
No.
No. That's as matched as they get. I get
Yeah.
the wife's data because I got the husband's data. I get the husband's data because I got the wife's data. Right? Like, they are inextricably connected. Alright? Nate or Sprig, was it you that had a question?
Oh, no, I figured it out.
Okay. Alright. That was progress check B. Now 2 on progress check C.
I got scared because I looked at it, I was like, oh my god, how did I make 5?
But you only had to do 6.
Yeah.
Numbers 2 and 4. Number 2. Alright, 2 95% confidence intervals were oh, y'all kill me on this one. Guys, and girls, and ladies, and everything in between. Like, I need us to recognize when we are going from size 400 to size 100, how are those related?
Times 2, or 1/2, whatever.
Well, so what we need to recognize is that it's quadruple this, right? So how are the widths of those intervals going to be related?
The widths
The
are
square
on
root.
both sides.
Yeah,
What?
but you also don't need that much. Like,
Wait.
remember,
Because of the,
plus or
standard
minus.
thing.
and so like here, it's not even the
Square
square root. Yes, right. So with hypothesis or with proportions, it was that, but here it's just literally s divided by the square root of n. Now we've got 4n, and what's the square root of 4? 2. So how much do we get? Half. There's quite a few of us. So first we need to recognize that it's the square root of 4, right? So like if it was times 9, what would happen to the interval width? It would be 1/3. If it was times 16, it would be 1/4, right? So if it was times 2, the interval width would be,
If it's an apple,
That's not perfect square.
Yeah.
so
Mr. Can apple think about this.
that's how the interval width would be affected. You're right, it's not a perfect square, but you can still do that, yes, and
I'm confused.
what are you confused by?
Can you like start back from where you did the equation? Because after that, I'm lost.
My point was we went from size 100 to size 400. So we took the sample size and we multiplied it by 4, right? What's the square root of 4?
2.
Okay. So what we have is s divided by 2 root n, or 1/2 of the previous standard error. So if the sample size is quadrupled, the width is 1/2.
Okay.
That's it. Okay? But notice that means the width of I-400 is not twice the 100, it is half, right? Variability is decreased by that. And finally, before DYU, are they asking for, thank you, how to interpret a correct interpretation of a confidence interval? I'm trying to remember which
This was
answers.
hard.
Oh no, I remember this one. Nope, we did not read this question correctly. Does it ask for a confidence interval interpretation? No, what does it ask for?
Level.
Confidence
Level.
level. So remember, in a confidence interval, we're 95% confident that the interval from here to here captures the true difference in mean strengths. But in the confidence level, why are we that confident? Because in repeated sampling,
I got my answer.
95%.
95% of the intervals capture the
Parameter.
parameter. So the interval doesn't matter. Notice interpreting confidence level, I don't care about the interval.
Do I?
In repeated samples of the same size, approximately, no, because we don't care about the interval. There we go. Approximately 95% of the intervals constructed from the samples will capture the population difference and means. The confidence level is about the capture rate. And that's why we had to use those t distributions to make those intervals wider to get the right capture rate.
Why?
So confidence level is all about capture rate. Yes, and I.
How I know what teams like random, not random. You know what it is when you check one portion.
Huh?
You know when you check portion.
Is that why?
Your Y, which means
I
you
mean,
get more food.
You need to check randomness, so it either needs random sampling or random assignment.
Yeah, how do I know which one teams you
Did Brady
Like
It
check
based
says
off
it
the
in the
question? I don't
words.
know. Okay.
Yes, he had something for HOSA.
Hosa?
So I was Hosa, but never us.
The other thing I was gonna say is you always need to check 10% if it's random sampling, right, without replacement. If it's not random sampling without replacement, then you don't have to worry about it. And then, so go ahead and clear your test off. You can have a formula sheet and a t distribution chart. If you need a blank copy of one, you can get that.
What if Serena's not called that?
Yeah.
Mr. Kenny.
And then you need a calculator. Yes, sir.
For the check thing, I know for like means,
Yep.
does it have a name for the thing when it's like, there's no like obvious outliers? Or is it just?
So it's still
Or you
just
just write
about is the sampling distribution approximately normal?
Yes.
So what you would just say, hey, the data does not show any heavy skewness or outliers, so we believe the sampling distribution, it could be
So
approximately
it has
normal.
no like name like CLP.
34, you just use 30.
Okay.
But I mean, you could also just run the test in the calculator.
Degrees of freedom is just the.
But I know to put for
It's
the
just N minus
calculate
one.
portion.
Huh?
Just add minus one.
I know to put for
Oh,
the
okay.
calculate
Mr.
portion.
Kenny, can I address you before we start?
We start now.
I'll wait a little bit.
All right. Just as a quick note, 'cause I hear y'all talking about the, which actually, Michael, can you pause it for a second?
Sure.
'Cause I'm about to upload this, but I hear y'all talking about like the, what is it, t-value for that one question, right? It's just the silver button on the back right.
The 17, the FRQ.
Silver button.
On the righty.
Low key.
Except by roll it, I mean record it.
Yep, got you. Our mock exam is the 27th, right?
26.
26, okay.
It's
Right.
the 28th, I think.
No, it says
26.
26.
Okay.
Am I crazy?
Is,
Yes.
Yeah.
are we gonna
The 28th is
learn,
a Monday.
Mr. Kenny, are we
It
gonna
was either
learn?
the 26th or the 27th. What's up, Mike?
It says 21st.
Ah,
Not for AP stats.
That's what I'm reading.
We gotta learn linear
It's 26.
regression before
Yes,
It's
ish.
not gonna be on the mock then, or?
It'll be on the mock still, but it'll give us a good picture of where we are. Okay. All right. We will. Yeah, we should be able to get there in about 2 weeks, or at least close enough.
11.
All right. So, real quick reminder. So this is off 11.1, the introduction to significance test for a mean. First off, when we do hypotheses, always make sure you define your parameter mu with confidence intervals as well. Don't forget your null hypothesis is always a statement of
Like not balance, but like equal, like.
so equality.
Yeah, equality.
Right.
I thought it was inequality.
Not for the null.
Oh, not for the null.
Yeah, the null is always a statement of equality. Mu equals something. And then the statement, the alternate is a statement of inequality. So less than, greater than, not equal to. Okay? I think the 21st was one of the, no. 21st was never an option even. We said 19th, 20th, 26th, or 27th, and then we went with 26 based on what we said. I think we talked about that in class. That
Isn't the 21st Monday?
No, the 24th?
You're thinking about the, not mock exam, you're thinking about the AP
Oh.
exam, but that's not for
Yeah,
you,
we're
that's
doing
only
this
for the seniors.
Yeah, we're doing the 26th.
Yeah, the 21st is a Monday.
Yes.
April.
Alright, so remember when you do a full conclusion for now, and I'm gonna give you again some things to make this easier towards closer to the AP exam, I want you to do everything all the way, and then when we get to the AP exam, we can back off a few of these things. But interpret your p-value. When we interpret a p-value, what do we always assume to be true from the beginning?
The null.
The null. So if you're ever asked to interpret a p-value, assuming that whatever the null is true, this is the likelihood of getting this or more extreme, right? And then you make a conclusion about the null hypothesis. What kind of conclusions can you make about the null hypothesis?
You either reject
Or fail to reject, right? So you either reject the null or you fail to reject the null based on the amount of evidence for the alternative. You reject the null when there is
Convincing evidence.
convincing evidence for the alternative. You fail to reject the null when there is
Insufficient.
insufficient evidence or not convincing evidence for the alternative, right? And so, do we have convincing evidence when the p-value is less than alpha or greater than alpha?
less
Less
than.
Less than alpha. Most students make the mistake, or when students make this mistake, they think, oh, a greater p-value means that it is more evidence. But no, that's less evidence. We want to know how unlikely it is by chance alone. So keep that in mind. All right. So this is what we started, or we basically wrapped up on Friday. So I couldn't remember how much y'all already had written down, so I went ahead and wrote this up here from 11.2. So we did a one sample t-test for a population mean. Our parameter was mu, the true mean normal body temperature. We have a significance level of 0.05. We have our statistic. We have our evidence for the alternative. Now, again, I don't write this in my choose. I focus on the procedure, the parameter, the hypotheses, and the significance level. That's what I put in my choose. This will come up in your calculate and in conclusion. All right, so check. Not really a simple random sample, not really a random sample period, but we just kind of let it be at this point. Is it safe to assume 10 is less than 10% of all high school students?
Probably.
Probably, yep, 100%. What's the last condition I have to check?
Approximate normality.
Approximate normality for the
Mean
sampling distribution, right? So, did we have enough to determine approximate normality for that sampling distribution?
Not for
No.
with
Have
the
enough of
CLT.
what?
Not for central limit theorem, right?
Yeah, no.
The central limit theorem, our sample size needed to be 30 or greater. Could we use the other condition of the population was approximately normal?
Yeah.
Yes.
There's no.
No, there's no.
I said, we don't know the population, right? That's kind of the big idea. So we had to look at the
Graph.
shape or the graph of the sample. And so that's what we did. I did a box plot. Is that, there's no heavy skewness. In fact, it's almost symmetric. And there's no apparent outliers. So it is safe to assume the sampling distribution is
That's
approximately
what I was
normal.
asking for earlier.
Yeah, and I told you that that wasn't going to be there. If you noticed, even on that problem, n was greater than 30.
For real? Oh my gosh, it was.
Yeah, it definitely was.
Oh my gosh.
You can do it both ways because I gave you that
Oh, yeah,
detail as
yeah.
well.
Oh my gosh.
But you always want to check that central limit theorem.
30.
This is a stopgap if they don't satisfy central limit theorem. Yes, Nate?
Do you always have to say safe to assume?
Yeah, I would always say it that way. It is safe to assume or believe the sampling distribution is approximately normal. So we don't know. We haven't proven anything. It's safe to.
For all the
believe
AP
that.
questions, it's always gonna be like all the conditions check out, right? Because
Because
I don't think they're gonna give you a question that's like
So,
not gonna check
Let's
out.
hear this question, and I need y'all to hear me on this. If they are asking you to conduct an inference procedure, the conditions will check. If they don't,
Yes.
you need to recheck stuff.
Yeah, I would check. 'Cause,
So
like,
they ask you to do an
that.
inference procedure. However, they will sometimes have questions where they are specifically asking you, do the conditions check out, or what is the problem with this, etc. Especially on like a problem 6, there may be a problem early on, and then they're like, okay, change this thing, or do it this way. Yeah, all right, all that to then say we did our calculate, we got our t-score. So remember, general formula, you go to that formula sheet, the critical value, not critical value because it's not a critical value, the standardized test statistic minus parameter divided by standard error. Plug everything in or substitute everything in from the formula sheet, substitute our values in, draw your distribution. Why in the world did I circle this tail and this tail?
That's two-tailed.
It was two-tailed. Remember, we go back to the very beginning right here, and it was a not equal to. How do we know from the beginning it was a not equal to?
Because
That's
that's
difference.
because it said is different from the doctor's claim. And like realistically, did we know if it was going to be greater than or less than from the beginning? No, so different than is a good alternative there. All right, now so notice I had to do both tails. So really I had a t value of -9, boom. And so I would go to the same distance on the other side. And I kind of just put a line there because -9 is so stupid far away, yeah. So notice, I wrote it here, you can just write p-value equals this, 8 times 10 to the -6, but also we would want to notice it's 2 times the probability of it being less, right, because it's less or greater. Alright, last thing, conclude, assuming that the doctor's claim was true, that mu is 98.6, what is the likelihood we get this statistic or more extreme on this side or the equivalent on the other side? It's effectively 0, right? It's effectively 0. So what do we do for our null hypothesis?
You reject.
We reject the null hypothesis, put in your context, because there is convincing evidence, sufficient evidence, significant enough evidence, all those would be acceptable for the alternative that mu does not equal 98.6, okay? Please do notice that at this point, you have to have context at least once in that conclusion. You have to have context at least once. All right, so real quick note, if we were to construct a 95% confidence interval, would that interval contain 98.6?
Wait.
Huh? If we were to construct a 95% confidence interval, would the interval contain 98.6?
What's the meaning?
No.
Can we look at the other thing again?
Probably not.
Oh.
It's super unlikely.
I was saying, we just did the hypothesis test, right?
Yeah.
We rejected the null hypothesis that mu is 98.6, so should that be inside of our interval?
No.
No, right? And that's what we want to recognize is the confidence interval especially should tell the same exact story as a two-tail hypothesis test. And so, especially because it was so unlikely here, right? It was so unlikely, there's almost no, it definitely should not be captured by that interval, right? So the confidence interval, the hypothesis test, need to tell the same story. One is just estimating a parameter, or giving us an interval to estimate the parameter. The other is collecting evidence for an alternative. All right, so here's what we need to remember. 4C method of inference, right? Do not forget to do all 4 steps, Michael.
Hey, okay, I didn't see the interpret, I just saw like the calculate.
It doesn't matter. Unless they tell you to not do the full procedure, you do the 4C method.
Okay. I just
Okay, so if they say calculate and interpret this confidence interval, do the 4C method. If they say, is there convincing evidence of this, do the 4C method of inference, right? They want you to do all those things.
I only need to do it because you gave us all that room. And
Yep,
time.
that's a good hint as well.
And time.
Yep. All right, so choose your procedure, your alpha, all those things. Check your conditions. I'm trying to remember why I specifically circled the calculate and conclude.
Formulas maybe.
Yeah.
Yeah, there's something specific that I wanted there. Let me see. Maybe I should have gone back and checked that.
check your understanding.
You checked your understanding.
Can't do this anymore.
She get all salty because I said you check your understanding.
Can we have nap time, you guys? I'm really tired.
Right.
I'm not looking out the window.
No,
Oh,
no,
that's
don't
what it
look out
was.
the window. Do that during the AP exam, not right now.
Okay, that's what I thought.
Bro, it better
Okay,
not be hot in that
So under the
classroom.
calculate,
I'd die.
the one thing that I want y'all to remember is draw your normal distribution. So draw the normal distribution. I should say approximately normal because it's not a z distribution, but a t distribution. But shade it, okay? Using the alternative hypothesis. The AP readers love to see that you marked your t distribution or t-score value and you shade it in the correct direction of the alternative. So if it's a greater than, you're going to shade to the
Right.
and if it's less than, shade to the
Yeah.
left. This will also help make sure you don't make mistakes when it gets to two sample stuff, when you actually draw it out, okay? Because we saw it on the last test, last unit, where a lot of us got the wrong p-value because we did the wrong direction on the alternative. In the conclude, what do you gotta make sure you include?
Context.
Context, you gotta make sure you have context. You gotta interpret the p-value, you've gotta reject or fail to reject the null, look at the alternative, etc. Making connections. So if we reject the null, what does that tell us about a confidence interval?
Reject the
Yeah.
It won't be not good.
Mu is probably not,
No. No.
yeah, is probably not captured by the interval. And good note on that, Peter, that it's the null hypothesis, right?
Probs.
So if we fail to reject the null,
It's probably.
it's probably captured.
Probs captured.
I don't appreciate this gangster lingo.
Prob. That's short for calculate, by the way.
Gangster lingo.
Yeah, no, y'all are getting a 0 on your ACT writing.
Well, actually,
She-
I got
she's done.
like a 9 on my
Alright,
writing.
So if the null is in the interval, if the null is not in the interval, right? So fail to reject or reject. Should have remembered that was in there. Alright, I know I need to do quite a few check your understandings. I'll work on those immediately after school for a little bit and upload several of them. So I think this is a very relevant question today, since we found out some of us are having to do the alternative test, right?
Bro, I feel bad for Braden.
So,
What happened to Braden?
well,
he can't take the makeup, so he has to take the one.
yeah,
Why can't he take
he
the
and I are trying to talk about it, because I would prefer him to
He's
take
going
the
on a
makeup,
camping trip.
but
Yeah, and
Yeah.
he has everything booked already, so.
he and I are talking about it. Alright, so is one form of the AP exam harder? So last year, East Kentwood High School had 30 students take the AP
What's that
stats
East
exam.
Kentwood? Who is
Huh?
East Kentwood?
So East Kentwood is where one of the creators of mathematics is a teacher. They were informed later that the College Board gave 2 forms of the exam, which were randomly assigned to the students. Here are the results. And so we have Form A and we have Form B. And in Form A, the mean is 4.2, the mean of B is 4.0. Does this result provide convincing evidence that one form of the AP exam is harder? So first, I do want to ask, is there evidence that one is harder?
Yeah.
There is evidence. Is it convincing though?
No.
We
We
all know
don't know yet. That's the proper way to respond. We don't know yet. So we're going to look at it. Now, I have an important question for you. Do we have paired data?
Mr. Candy,
No.
can you turn off the light, please?
No, because not every
No.
student
Thank
took
you.
both exams. If it was every student took both exams, we would have paired data, but since
That
we
is-
didn't, we don't.
One way to do it, every student took both exams so that we could directly compare.
There's no relationship between the students who took the exams.
And we don't know, right? They were randomly assigned to the different groups. What about if we had taken the 2 students who had the highest grades in the class and assigned one to Form A and one to Form B, and then the next 2 highest grades in class and assigned one to Form A and then one to Form B? There's at least some correlation there, right? Yes, it does not perfectly explain everything, Jaden, but could grades reflect the scores on the AP exam?
100%
Huh?
pass rate.
Say again?
That's a 100% pass rate. It's good.
Not quite 100.
No, I meant Form A.
Yeah, Form A.
No.
Because I can tell you this, it's not true in every class, but my grades pretty well explain the AP scores. Like traditionally, if you make an A in my class, you are making at the bare minimum for probably a 5. If you make a B in my class, you are looking at a 3, maybe a 4, usually somewhere close to a 4. Okay, so like those are the realities. Like grades can reflect it depending on how teachers do it. Anyways, does this result provide convincing evidence? So what is our statistic here that we are looking at?
X bar.
X bar
equals.
X bar 1 minus X bar
Oh,
2.
yeah. Wait, no.
Wait, no.
X bar.
What?
No.
I would do X bar A minus X bar B.
Bruh.
Why are we gonna do those here?
This
Because
is Form A and B.
Form A and Form B,
Extra.
could you do 1 and 2?
Yep.
Yes.
Yeah.
Is it as good as A and B? No. Okay. So our statistic here, by the way, do we know these values?
Yeah.
I mean, basically.
Not basically, we know them.
Yeah.
It's 0.2, that's the difference in X bar A and X bar B. Sample means, alright. Parameter. What is that?
The true
difference
difference of
between
X bar
all
A.
students who take
Right.
the statistics test Form A subtracted by Form B.
True mean. I wouldn't say mean difference.
True difference in means.
True difference in means, because remember it's not paired data. True difference in means. Mean scores for those who take scores for AP stats students who take
Oh my god.
Form A minus Form B.
Whole paragraph, right?
True diff.
I feel like I didn't write in present tense on my test.
You're just bad.
I'll look at it. Just be careful with it. You do, because you don't want to make the language about the sample, but be careful about it. They are nitpicky. All right. So we don't have paired data. So there are two possible explanations for why Form A had a higher mean. There is no difference in difficulty. The result happened purely by chance. What is that also going to be called?
No.
That's my null hypothesis. And what is that null hypothesis?
0.
Yeah.
Well,
H
X
of
minus whatever equals 0.
U of A minus U of B
H of L
equals 0.
equals.
Equals 0.
Sorry.
The mean, the difference in the means is 0.
So there's no difference.
The alternative is
H of A.
The difference is the means not equal to 0?
not equal to 0.
Higher mean, so
Well,
What does
it says harder, right?
If
Uh,
A,
yeah, we'll
so
say number
it would
one.
be positive, it would be more
yeah,
than
it'd be
zero.
positive. So
It
greater
says
than
one
0.
form is
Oh, wait.
It doesn't.
Harder.
Does it just say one form is harder?
Yeah.
Yeah,
it says
So
that.
not equal to. Yep, good job, not equal to. Yeah, you don't want to,
How many points off would that be?
they would make it way more clear on the AP exam than that, okay. Alright, so what we're going to do, at least start out today, you should have
Yeah.
a set of, yep, so I need you to cut out,
What?
I
Bruh.
didn't see there it is.
let me find all of my scissors. I need you to cut out the possible AP scores right there.
AP art class.
What happened to these scissors?
What?
How are they green and white?
Because
Don't be racist.
high school students get bored and apparently draw on scissors.
Bring this down.
Okay? So,
It's gonna make us like mix this with.
so we're gonna assume there is no difference in difficulty. And so if Doug scored a 5 on A, he would score a 5 on B. And so we're going to randomly assign these scores to Form A. So what are we gonna do to randomly assign half the students to Form A and the other to Form B?
First label all the students one to
Random
however many there are.
generator.
So there are 30 students, I think?
Wait, with unique numbers.
Yeah, so I will point that out. You could, there's one option, and people do this on the AP exam all the time, where you put all of them in a hat and you shake it up and you draw names. No, I would number these 1 to 30.
I thought you had to
Okay.
say 1 to 30 with unique numbers. Or
Well, so remember what I said is, sometimes on the AP exam, what I was saying is, they put all the values in a hat, shake up the hat and draw numbers. I don't like that.
I like writing that because it's, you don't have to write.
It's so dicey though, because you actually have to be very intentional with the language. Please do this for me. Label every card with a unique number, 1 to 30. Randomly generate how many numbers?
My calls
You have to label these 1
Mr. Kenny.
Hold on one second. Say that one more time.
Do we have to like write a number on the back, 1 to 30?
I would just put it on the front. It doesn't matter, right? Okay, so label them 1 to 30 with a unique number. How many random numbers do you need to generate?
Never mind.
How many? 15, and let's say that they all get form A, right? Okay, and find your mean difference, or your means. Find the difference in those means. What I will say is this, we're not going to be able to quite finish this in class, so what I need you to do is I need you to do this twice before you come to class tomorrow. So if you want to do that before the bell rings, knock it out. If you need to do it twice, or do it a second time before class tomorrow, you can do that, but I need us to be able to put the data on a graph as soon as you come into class tomorrow.
Wait, why do we need to